Why is the sky blue and the sunset red? The colours of the universe, created by light and air. When we open the window in the morning, the sky is simply there. It is so familiar that we rarely stop to ask, why is the sky blue? Why does that same sky turn red in the evening? If sunlight looks white, why is the daytime sky blue while the sunset glows red? We tend to think of the sky as a background. It stretches above mountains, between city buildings, and over the ocean. It feels like a vast blue ceiling hanging over the world. But the sky is not a ceiling painted blue. The sky itself is not a blue object. What we call the colour of the sky is a trace left by light as it travels through the atmosphere. The blue sky we see every day is actually one enormous experiment created by light and air. The sun sends out light, Earth's atmosphere receives it. Air molecules scatter that light, and our eyes and brain translate the scattered light into colour. So the blue of the sky is not created by the sun alone. It is not created by the atmosphere alone. And it is not created by our eyes alone. It emerges from the meeting of sunlight, atmosphere, and observer. Let us begin with sunlight. To our eyes, sunlight appears white. But white light is not a single, simple colour. Inside it are red, orange, yellow, green, blue, indigo, and violet. Think of what happens when white light passes through a prism and separates into a rainbow. White light is not empty light. It is light in which many colours are superimposed. Red is there, blue is there, violet is there. When we receive them together, our eyes experience them as white. So if we want to understand the colour of the sky, the first thing to remember is this. Sunlight is not one colour. It is a chorus of many colours. Then what exactly is colour? Light is an electromagnetic wave. In simple terms, it is energy travelling through space in an oscillating pattern. And the colour of light is related to the spacing of those oscillations, its wavelength. Red light has a relatively long wavelength. Blue and violet light have shorter wavelengths. You can imagine long wavelength light as a broad, relaxed ocean swell. Short wavelength light is more like a tightly packed ripple. Colour is not clothing worn by light. Colour is the difference in light's rhythm. Red has one rhythm. Blue has another. The colours of the world are, in a sense, different rhythms of light arriving at our eyes. Now let us think about Earth's atmosphere. We cannot easily see air, so it is tempting to imagine that air is simply transparent emptiness, doing nothing to light. But the atmosphere is not empty. It contains molecules such as nitrogen and oxygen. It also contains tiny amounts of dust, droplets, and aerosols. When sunlight reaches Earth, it must travel through this enormous layer of atmosphere and encounter countless molecules along the way. During those encounters, some of the light changes direction. Instead of continuing straight ahead, some of it spreads sideways, upward, downward, and in many other directions. This is called scattering. Scattering does not mean that the light disappears. It means that the light is redirected and spread out. You might think of fragrance spreading through a quiet room. In a similar way, sunlight spreads through the atmosphere. Air may be transparent to us, but for light, it is not silent emptiness. It is a place of countless interactions. Now we arrive at the central reason the sky appears blue. Tiny particles such as air molecules scatter shorter wavelengths of light much more strongly than longer wavelengths. This phenomenon is called Rayleigh scattering. Blue light has a shorter wavelength than red light. So when sunlight enters Earth's atmosphere, blue light is scattered in many directions much more efficiently. When we look up during the day, we are not only seeing light coming directly from the sun, we are also seeing blue light that has been scattered toward us from all across the atmosphere. That is why the entire sky appears blue, not just the region near the sun. Blue light is arriving at us from many directions. The sky is blue not because it is made of something blue. It is blue because the atmosphere scatters blue light across the sky. But then a very good question appears. Violet light has an even shorter wavelength than blue light. So why is the sky not violet? This is an important question because nature is rarely explained by one factor alone. Several effects work together. First, the sun emits less visible violet light than blue in the part of the spectrum most relevant to our vision. Second, the human eye is less sensitive to violet than to blue. And third, some of the shortest wavelength light is weakened by processes higher in the atmosphere. Together, these effects cause us to perceive the daytime sky as blue rather than violet. And now we see something deeper. The colour of the sky is not only a story about the physics of light, it is also a story about the eye and the brain. The sky is a phenomenon outside us, but the experience of its colour is completed inside us. Now let us move toward evening. During the day, the sun is high in the sky. Sunlight travels through a relatively short path in the atmosphere before reaching us. Along that path, much of the blue light is scattered away in many directions. That scattered blue light is what makes the daytime sky blue. But as evening approaches, the sun moves closer to the horizon. Now the sunlight must travel through a much longer path in the atmosphere before reaching our eyes. the journey becomes longer. During that long passage, more and more of the short wavelength blue light is scattered away. Much of the blue has already been redirected elsewhere. What remains along the direct path toward our eyes is light that is relatively richer in longer wavelengths, red and orange. And that is why sunsets appear red. The sun itself does not suddenly become red at the end of the day. The light has simply travelled through a much longer layer of atmosphere, losing much of its blue component along the way and leaving the redder light to reach us. A sunset is not red because the day is ending. It is red because the light has completed its longest journey through the atmosphere. Perhaps that is why sunsets feel so emotional. The blue sky of daytime is young and expansive light. It is light scattered everywhere. It surrounds us from all directions. But the red light of sunset has travelled a long road. It is the light that remained after so much of the shorter wavelength light was scattered away. And maybe that is why we sense time in a sunset. A sunset is a physical phenomenon of light, but it also feels like the memory of a day, as if all the hours from morning to evening are folding themselves into red along the horizon. Science says, short wavelengths scatter more. Long wavelengths survive the long path better. But the human heart may hear something else. What is easily scattered disappears into the distance. What endures the long journey remains glowing at the end. This is where science and the humanities can meet. Physics explains the mechanism. The human mind gives that mechanism meaning. Then why are clouds white? Clouds are made of water droplets and ice crystals that are much larger than ordinary air molecules. Tiny air molecules scatter shorter wavelengths, such as blue, more effectively. But the much larger droplets inside clouds do not strongly select only one part of the visible spectrum. They scatter red, green, and blue light more similarly. When many colours are scattered together, we perceive the result as white. That is why clouds look white. But when a cloud becomes very thick, less sunlight reaches its lower regions. Then the cloud appears grey. Grey is not necessarily a completely different colour. It is often white with less light. The blue of the sky comes from the scattering behaviour of tiny air molecules. The white of clouds comes from larger droplets scattering many colours together. The grey of a storm cloud comes from reduced light. The size of particles changes the colour of the sky. Now let us leave Earth for a moment. Would the sky on another planet also be blue? Not necessarily. The colour of a sky depends on the colour of the star, the composition of the atmosphere, the sizes of particles floating within it, the amount of dust, and the kinds of clouds present. Earth's blue sky is the special result of Earth's atmosphere, sunlight, and human vision. Consider Mars. The Martian atmosphere is much thinner than Earth's and contains large amounts of fine dust. Those dust particles scatter light differently from Earth's air molecules. As a result, the daytime sky on Mars can appear reddish or butterscotch-coloured. And something even more interesting can happen near sunset. Under certain conditions, the region around the setting sun can appear bluish. On Earth, we are used to a blue day and a red sunset. On Mars, the pattern can look strangely reversed. If we travel farther to exoplanets, the possibilities become even more extraordinary. One world may have a methane-rich atmosphere. Another may be covered in sulfuric acid clouds. Another may have a thick hydrogen atmosphere. Still another may be filled with dust or ice crystals. Its sky could appear violet, golden, brown, perhaps greenish, or something difficult for us even to imagine. There is no universal standard colour for a planetary sky. The sky is the face of a planet. Its colour carries information about atmospheric chemistry, particle size, cloud structure, and the light of its parent star. If extraterrestrial life exists somewhere, it may live beneath a sky completely different from ours. To such beings, a blue sky might seem exotic. Their sunsets may not be red. They may be blue, purple, gold, or something beyond our familiar palette. The blue sky we take for granted is actually one of Earth's unique sensory inheritances. And now we arrive at an even deeper question. Is the sky truly blue? Or is blue what our eyes and brain make of it? Light has wavelength. That is a physical fact. But the sensation of blue is an experience constructed by our nervous system. Other living creatures can perceive the same sky differently. Bees can see ultraviolet light that humans cannot. Many birds possess colour vision that extends beyond our own. Some animals are far more sensitive to brightness or motion than to colour. So is colour something that exists in the world? Or is it something created by perception? The answer lies somewhere between the two. Colour is not created by light alone, nor is it created by the eye alone. Colour is a translation created by light, the eye, and the mind together. The blue of the sky exists outside us, and at the same time it exists inside us. Only when the universe sends certain wavelengths, the atmosphere scatters them, our eyes receive them, and our brains interpret them, does the experience called blue sky emerge. This is not just a question about vision. It is a question about how we experience reality. We often feel as though we see the world exactly as it is. But the world is always translated through our senses. Light becomes colour. Vibrations become sound. Chemical signals become smell and taste. Human beings do not simply copy the universe. We translate the universe into the language of our senses. Then how might we look at the colour of the sky from an IG perspective? In standard science, the explanation is already strong and complete at the physical level. The colour of the sky is explained by the wavelengths of light, atmospheric molecules, Rayleigh scattering, and human colour perception. That framework already tells us why the sky is blue and why sunsets are red. But from an IG perspective, we can add another question. Is colour a property possessed by an object alone? Or is it the way information appears through relationships? The blue sky does not emerge from the sun alone. It does not emerge from the atmosphere alone. And it does not emerge from human vision alone. Only when sunlight, atmospheric molecules, scattering paths, and an observer's sensory system come together does the experience we call blue sky appear. From an IG perspective, colour can be interpreted as a relational output of information. Wavelength information in light interacts with the atmosphere. During that process, shorter wavelengths are scattered more strongly. That scattered information reaches the observer, and the sensory system reconstructs it as the experience of blue. So the blue of the sky is not simply a fixed material property, it is the result of an informational relationship among sun, atmosphere, and observer. The sunset is similar. The red of sunset does not mean the sun itself has become red. It means that light has travelled through a long atmospheric path, losing much of its short wavelength contribution, while leaving the longer wavelength contribution relatively enhanced. A sunset is, in this sense, filtered information. It is colour information that has survived a long journey. From this perspective, the sky is not merely a background. It is an enormous information screen. The sun sends information. The atmosphere filters and scatters that information. The observer reads it as colour. We do not simply see the sky. We see the result of light information transformed by atmosphere and perception. Of course, this IG interpretation is not a replacement for Rayleigh scattering. It is an informational and philosophical layer placed on top of the established physics. The scientific mechanism lies in scattering. The broader interpretation lies in the relational nature of information. So from an IG point of view, we might say, the colour of the sky is not a colour owned by an object. It is the face of information that appears when light, atmosphere, and observer meet. Now let us return to the question we began with. Sunlight is white, but that white light is not one colour. It is a chorus of many colours. When it enters Earth's atmosphere, short wavelength blue light is scattered in many directions. That is why the daytime sky appears blue. In the evening, sunlight must travel through a much longer path in the atmosphere. More of the blue light is scattered away. Red and orange light become relatively dominant along the path toward our eyes. That is why the sunset appears red. The daytime sky is scattered blue light. The sunset is red light remaining after a long journey. The sky we casually look at every day is actually an enormous laboratory. The sun sends light. The atmosphere scatters that light. Our eyes translate the result into colour. To look at the sky is not simply to look upward. It is to watch the universe explain itself through light. The morning blue sky seems to say, light can scatter without disappearing. It can return to us from another direction. The evening red sky seems to say, there is beauty in what remains after a long journey. The white cloud seems to say, many colours together can become one brightness. And the unfamiliar sky of another planet seems to say, the colours we know are not all the colours the universe can create. Perhaps the sky is humanity's oldest science book. Without turning a single page, it performs experiments in light and atmosphere above us every day. And at the same time, the sky may be humanity's oldest poem. Science explains why it is blue. The human heart feels vastness in that blue. Science explains why it is red. The human heart feels the ending of a day in that red. That is the beauty of the sky. It is both a physical phenomenon and an emotional landscape. It is light scattering and memory. It is atmospheric optics and a mirror of the human mind. So the next time you look at a blue sky, perhaps you can remember this. That blue is not paint spread across the heavens. It is sunlight meeting air, scattering in every direction, and finally arriving at your eyes. And the next time you watch a red sunset, perhaps you can remember this. That red is not sadness painted onto the end of the day. It is light that has travelled one of the longest paths through the atmosphere and still reached you. The blue sky is the beginning of light's journey. The red sunset is the memory of its long passage. And between them, we continue to look up and witness the colours of the universe. This has been ThothSaem's Science Catch.